with the help of the identities we were doing proofs. Only like one or two we have done yesterday. We'll be doing more today. So the next question is, just a second now. Yeah. Next question is this one, which you will be able to do by yourself. Cos A by 1 plus sin A is there. Okay. We are not going to do it together because let me give you a hint how you will proceed from here. Just you will take the LCM and you will do the addition, the fractional addition you will try doing over here. You will end up getting the other side. Okay. Directly you will not get, of course. A few simplification will be there. Maybe you need to use the identity in between, but you will be able to do it by yourself. Okay. You just have to try doing the addition by taking the LCM of the denominator. Okay. Next one we'll be doing together. That is this one. Tan theta over 1 minus cot theta plus cot theta over 1 minus tan theta, and we need to show that it is equals to 1 plus sec theta cosec theta. Okay, I told you, when you are not getting anything, you can first pick any side, left hand side or right hand side. We will be picking left hand side because here we can work more, like more simplification will be possible on left hand side, and hence it will be better to pick left hand side. Okay. Now once you will pick left hand side, you can see here tan is there, cot is there, and when we are not getting anything, we will be converting tan in terms of sine and cos. We will be converting cot in terms of sine and cos. Let's do it. And then we will keep on doing the simplification, whatever will come in our way. Okay, there is no proper method to do the proof. If you are practicing and like for the very first time you are doing the practice, you are solving few questions, you already know the proof. Don't think that this way like you will be able to do, just you will memorize the steps from here and you will be able to do in exam like that only. No, it requires practice, and you will understand while practicing at home that every time, even if you are getting a new question, you just have to, like most of the time, tan will be sine by cos. You just have to keep on doing the simplification. You will get. And yeah, the simplification part must be clear to you. If you are confused with addition and subtraction, then definitely you will get stuck over here. Cos theta by sin theta over 1 minus sine by cos. So far, any confusion? Any confusion so far? No. Let's continue. Now we will try simplifying the numerator. We will try simplifying the denominator. Numerator, we don't have anything to simplify. Sine by cos is there. We will keep it as it is. Denominator, we will be doing the simplification. So sine theta by cos theta. Okay, here LCM is sine theta. And what will be there in the numerators part? Can you tell me? Who will say?
Sin theta.
Sine theta minus cos theta. Here also we'll be having cos theta by sine theta. And in numerator we'll be having
Cos theta minus sin theta.
in numerator it will be
Cos theta minus sin theta by cos theta.
perfect. Okay, let's do the simplification. So now fraction by fraction we are having. We know we can write it as a sine theta over cos theta into the sin theta minus cos by sin is there. We can reciprocal sin theta minus cos theta, right? Similarly here also cos theta by sin theta was still there, and then the rest is cos by cos theta minus sin theta. Okay, any confusion so far? Anyone having any confusion so far? Can we proceed?
Yes, ma'am.
Yes or no? Yes. Okay, so we are having sin square theta by cos theta, and in bracket sin theta minus cos theta. Plus cos square theta over sin theta in bracket cos theta minus sin theta. Now both the bracket is not same, but we can make it same because still we need to do the addition. Okay, the fractional addition. We can make both the brackets same. A minus B type of structure is there in the first bracket, and B minus A type of structure is there in the other bracket. By taking out negative common, we can make both of them same. Either you can take out minus common from the first bracket, or you can take out minus common from the second bracket. Okay, then if we will take minus common from the second bracket, it will be sin theta minus cos theta. Everyone getting it? Getting it? Yes or no?
Can you scroll down a bit?
Up or down?
Down, like up. Yes.
Is it,
Yeah.
is it okay?
Yes.
So when we will take minus common from the denominator, it will be sin theta, cos theta minus sin theta we were having. It will be sin theta minus cos theta. Do I need to explain it? Please let me know. Whenever you are having A minus B, if you will take minus common, this A will be negative A. Check it. It became B minus A. Check it. It is nothing but B minus A. Minus A plus B means B minus A only. Are we doing any changes? No. Please open the bracket and check it. A is still positive and B is still negative initially the way it was. Getting it? We are just doing one arrangement. We are taking out minus common. Arrangement like this. If 5 a positive number you are having and you have to represent it in a with a minus sign, one arrangement you can do, you can write it as a minus of minus 5. Have you done any change? No, you have just changed the arrangement. Minus of minus 5 and plus 5 is the same thing. Getting it, everyone? I think you already know, that's why you are not responding. Okay, cos theta. Okay, here sin theta plus sin became minus sign because we have taken minus common. Cos is easier to take out the LCM. Now think about it. What will be the LCM for the denominator? Yes, who will say what will be the LCM for the denominators? Yes. What will be the LCM? डेनोमिनेटर का एलसीएम क्या होगा? Yes. What will be the LCM over
Theta
here?
sin theta and minus cos square.
What? Can you please repeat?
Cos theta sin theta minus cos theta square.
Cos theta sin theta. Yeah, cos theta sin theta will be there. Then the common part. In that chapter, if a question will come in your exam, that what will be the LCM of a cube b k and a square b? What will be the LCM? Yes, what will be the LCM of a cube bk and a square b? Yes,
A
I'm
cube
asking from
PK.
everyone. A cube bk. Yeah. Okay. While finding the LCM, first we find the common factor. A square is here also common. B is there, B is there, B is the common. Common we have taken. Now all the extras also we will pick. So A cube, from here, A was remaining. That is the extra we are picking after picking the common factors. And K is there. K also we will be taking over here. And hence LCM came out as a cube BK. Everyone getting it? If you are getting it, then please tell me the LCM over here. Sin theta cos theta into, is it sin theta minus cos theta? Is
Yes.
it so? Yes, it is so. Okay. We found the LCM. Now, what will be there in the numerators part? Sin square is already there. What we will multiply with sin square? See, match it. Whatever is extra, cos is there, cos is there. In LCM, sin theta, cos theta, this is already there. So whatever extra you multiply in the numerator also. Yes or no? पहले
Yes.
हमारा डेनोमिनेटर क्या था? cos थीटा sin थीटा माइनस cos थीटा. cos थीटा मल्टीप्लाइड विद sin थीटा माइनस cos थीटा. अब डेनोमिनेटर क्या हो गया है? अब जो एलसीएम निकल के आया तो डेनोमिनेटर cos थीटा इंटू sin थीटा एंड sin थीटा माइनस cos थीटा इन ब्रैकेट. तो एक्स्ट्रा क्या है? डेनोमिनेटर जो न्यू डेनोमिनेटर है, जो न्यू
Sin
डेनोमिनेटर
theta
है,
cos.
sin theta extra है, that only we need to multiply in the numerator also. Yes or no?
Yes.
Sin cube theta, if I will say, is it making sense to all of you?
Yeah.
Yes or no? Sin square पहले से था, one more sign we have multiplied. Let me break it, otherwise you will end up getting confused. Sin square was already there, we are multiplying sin with it. Is it okay?
Yes.
Minus, what will be there? Please tell me. Cos square was still there. I have copy pasted it.
Ma'am, into sin.
It will be.
Into cos theta.
Yes, Harshit, can you please repeat?
Ma'am, I think into sin theta.
Ma'am, into cos theta.
Yes, it will be cos theta just. Everyone getting it? How we do the comparison? Let me show you. At first this was the denominator previously. Now we are drawing a bigger line and writing one denominator, that means one. So we will be doing the comparison one by one. Okay, this 2 circle 1 denominator now change to this one. We will be doing the comparison one by one. First we will be doing the comparison of the first denominator with this denominator. Previously it was cos theta, sin theta minus cos theta. Now it is cos theta into sin theta minus cos theta. So what changes has been done? So we can see one sin theta is multiplied over here. With the first denominator, I am still comparing. So what we do with the numbers? Okay, please don't get confused. 1 by 2 minus 1 by 5 if you are having. Your LCM will be 2 into 5. That is 10. Right? 2 into 5 will. Okay. Now what we do? We just a second. We just compare with the previous denominator. Previously it was 2. Now 2 into 5 is there. 5 has been multiplied. So 5 we write in the multiply in the numerator. Multiply in the numerator. Okay. And these process we do so quickly without even realizing that what exactly are the steps we are following. Okay. Here you will be writing 1 into 2. Directly you will be writing 5 minus 2. Okay, what exactly you are doing in your mind? Let me help you recalling that 5 2 times 10 is the LCM. 2 5 times 10. You just start recalling the table to 1 times 2, 2 times 4 to 5 times 10. So 5 you multiply with the numerator also. Yes or no? Yes or no? बेसिकली व्हाट यू आर डूइंग, पहले जो डेनोमिनेटर था अभी जो डेनोमिनेटर है दोनों को कंपेयर ही तो कर रहे हैं. एक्स्ट्रा जो मल्टीप्लाइड हुआ है यहाँ डेनोमिनेटर में सेम नंबर वी आर मल्टीप्लाइंग इन द न्यूमरेटर आल्सो. यस और नो?
Yes.
Yes.
Okay. Now with the other one you do the same thing, but you do it so quick, and that time table is known, table is helping us. But sin theta cos theta, these table doesn't exist. That's why we are getting confused. Okay. So 5 2 times 10. 2 we quick we multiply 2 in the numerator and we just write 2. Without even realizing that we are multiplying 2 in the numerator. Okay. That's why here in our actual subtraction, see now, is it making sense? Cos square theta was already there and one cos theta came. Is it making sense to all of you?
Yes.
Is it crystal clear? In each and
Ma'am,
every problem we'll be doing the same thing. Yeah, Harshit, you want to ask anything? Please tell me.
ma'am, when we are multiplying the denominator, so in the bracket it should be sin theta minus cos theta whole square, no?
For the LCM you are saying, Harshit?
Yes, ma'am, for the denominator.
For the LCM, Harshit, recall that LCM means first we write the common factor. First we write the common factor. If this two circle, from this two circle, just a second. In this two circle, if I will ask you what is the common factor, Harshit?
Like sin theta and cos.
Sin theta minus cos theta in a bracket, yes or no?
Yes, ma'am.
So that is the common factor. When we find the LCM, first we write the common factor up. See, LCM of 2 and 4 is 4. You know that, right?
Yes, ma'am.
How it became 4? Because 2 means plus 2 and 4 means 2 into 2. So LCM, what we do, first write the common factor, that is 2. And then we take all the extra factors also, that is 2. And from here only the result came out 4.
Okay, ma'am.
Getting it?
Yes, ma'am.
Getting it, sine theta minus cos theta square will not be there because that is the common factor. And then all the extra sine theta and cos theta, that were the extra terms we have taken along with this bracket term. And hence our LCM is cos theta sine theta in bracket sine theta minus cos theta. That's why we made it same. This two bracket was not same, but we made it same because it was possible. Why? So that we will take the common factor as a LCM. Getting it?
Yes, ma'am.
Is it crystal clear now?
Yes.
Yes.
Let's continue. So can you see in the numerator we got sine cube theta minus cos cube theta? Can you see? Everyone? In numerator we ended up getting sine cube theta minus cos cube theta. Do we know formula of a cube minus b cube? Do you
Yes.
know what is the formula of a cube minus b cube?
A minus b into a plus b.
No. A cube minus b cube. In numerator it became sine cube theta minus cos cube theta. Do we know this
Yes.
type of formula a cube minus b cube in another bracket? Is it lagging a lot?
Yes, ma'am.
Okay. I'm going to leave and join. Okay. You have to continue this simplification. Let me give you the hint. A cube minus b cube formula is, write it. Please write it quickly. A cube minus b cube formula is a minus b in one bracket. In another bracket, a square plus ab plus b square. ए क्यूब माइनस बी क्यूब का फॉर्मूला है ए माइनस बी फर्स्ट ब्रैकेट में और दूसरे ब्रैकेट में ए स्क्वायर प्लस ए बी प्लस बी स्क्वायर। ओके, ये फॉर्मूला हमें अभी जो हमारे पास साइन क्यूब थीटा प्लस कॉस क्यूब थीटा है, not plus, minus, we will be using this formula over there. Okay, I am quickly going to leave and join, and you have to solve it in between. Okay.
Okay, ma'am.
Yes. Are you done till there? Yes, everyone. Are you done till there?
Yes.
Okay. Yes, please turn on your camera. Why everyone has turned off the camera? Yeah, we were here. And I told you that we are getting the, it looks like sine cube theta minus cos cube theta. That means a cube minus b cube, where we can use the formula. Okay, let's continue. A minus b in one bracket. In another bracket, a square plus ab plus b square over whatever was there. Now here, can you see that this one and this one is getting cancelled out? Yes, it is allowed because all are in multiplication and we are treating bracket as a single unit. Okay. So yes, we can cancel these two brackets. We are left with, in numerator, we are left with sine square theta plus sine theta cos theta plus cos square theta. In denominator, it is just cos theta into sine theta. Okay. Now focus. This is sine square. This is cos square. Both, if we will bring both together, sine square theta plus cos square theta, will it be 1? Yes or no?
Yes.
Yes. Okay. Plus sine theta cos theta over sine theta cos theta. Now check it. We are done with the proof. We are done with the proof. We can write 1 by sine theta cos theta plus sine theta cos theta by sine theta cos theta, which is, this is just 1. Okay. And the first part can be written as, since we want to prove, and if you will focus, the right hand side is, in right hand side sec theta cosec theta is there, so we can write it like this: 1 by sine theta into 1 by cos theta. We can write it like this, hence it will become cosec theta into sec theta. And we are done with the proof. Yes or no? Let's summarize from the beginning what we did. We were having tan theta by this, cot theta by this. We wanted to prove it is equals to 1 plus sec theta cosec theta. I told you, when we are not getting anything, always we will convert sine, tan, cot, cosec, sec in terms of sine and cos. So we did so. When we did so, we realized that simplification will be possible for the denominators part. We did the simplification. After doing the simplification, we ended up getting something like this step. Now again, it seems like simplification will be possible. But before proceeding, here we can notice that sine theta minus cos theta is there in one bracket, and there cos theta minus sine theta is there. So before doing the simplification, taking the LCM again, we will make the denominator same if that is possible. Okay. we have taken minus sign common from the other bracket and we made it. See, it was cos theta minus sin theta here. And we made it sin theta minus cos theta. Check it. How? By taking minus common. Here, negative sign came in between. Because we have taken minus sign common from this bracket. And that minus only we have written. That minus and plus became minus over here in between. Okay. Again, we did the simplification by taking the LCM. And here we are. One identity we have used in between. You must know all the identity. A plus b whole square, a minus b whole square, a square minus b square, a cube minus b cube, a plus b whole cube, a plus b, a minus b whole cube. Okay. All the formula must be on your tips. So we applied the formula and we ended up getting something like this. And from here, we got the proof. Okay. You just have to keep on going, keep on going. Automatically, you will end up doing the proof. Everyone getting it?
Yes.
Yes.
Let's continue. Just a moment. So here we are having the next question, which is also very important. 1 plus sec A by sec A is equals to sine square A by 1 minus cos square A, cos A. Okay. Let's try proving left hand side is equals to right hand side. We will be taking the left hand side LHS and it is 1 plus sec A by sec A. We know that whenever sec, cosec, tan, cot we are having, we can convert it in sine. And here obviously we will do so because the other side sine and cos is reflecting. Okay, let's do it. 1 plus 1 by cos A over just 1 by cos A. Now in numerator here simplification is possible and we will do so. Okay. LCM will be, what will be the LCM for the numerators part? LCM will be yes, numerators
Cos A.
cos A. Okay, here we'll be having in numerator we'll be having
Cos A plus 1.
cos A plus 1. If you understand simplification, then these questions are very simple. You will also feel that these are nothing like it's not that difficult. It's very simple. Only you have to keep on doing the simplification, whatever comes your way. So cos A plus 1 by cos A, and denominator we will write the reciprocal. That means cos A by 1. Cos A cosec on. We are having just cos A plus 1. Now what to do we are not getting. From this cos A plus 1, which identity to use, where to go, what to do, we are not getting. I told you simplification will keep on coming and you have to keep on doing that. But here, no more simplification is possible. We cannot add cos A with 1. Okay, we will leave it over here. Now we will take the right hand side. That is sine square A by 1 minus cos A. RHS we will take. Sine square A by 1 minus cos A. Now the numerators part looks like Yes, we can do we can use the identity. Three formula only we are having. Only three formula. Sin square theta plus cos square theta is equals to 1. Sec square theta minus tan square theta is equals to 1. Okay, cosec square theta minus cot square theta is equals to 1. So the first formula we can use over here for the numerators part. Tell me what can be written from this formula. We want to use this formula over here. How to use it for the numerators part? How to use it? This is just a formula. Sin square a, at the place of this, what can be written by using this identity? Who will say? Yes, who will say?
Sin A.
1
साइन स्क्वायर ए के प्लेस पे क्या लिख सकते हैं ये इस फॉर्मूला को यूज करके?
1 minus cos square.
1 minus cos square a we can write over 1 minus cos a. Whenever you will be having such a structure 1 minus cos square a, you can see it looks like a square minus b square. 1 is not a square, so what we can give it is square. Okay, a square minus b square structure we have created. Now a plus b in one bracket and a minus b in another bracket, and we are done. Can you see? We are done. 1 plus cos a we got, and that's what we have generated from the left hand side also. So even if we, after solving left hand side, we have not got right hand side, but separately we solved left hand side, right hand side, and both way, like by doing both, we are getting the same result. Can you see? Can you see?
Yes.
Hence we can say that. Hence, we can say that left hand side is equals to right hand side. We have done the proof. Sometime this way we will be doing the proof. Okay. Any confusion so far? Any confusion so far?
No, ma'am.
Okay. Just a moment. Let's take the next question. Cos A minus sin A plus 1 by cos A plus sin A minus 1 is equals to cosec A plus cot A. Okay, here it is written that we have to prove it by using the identity. Using identity, cosec square A is equals to 1 plus cot square. This identity we need to use to prove left hand side is equals to right hand side. Okay. If this condition will not be given, then we could have thought about doing any simplification or whatever, like any other way. But since it is given that this identity we need to use, let's pick the left hand side first. Left hand side is cos A minus sin A plus 1 over cos A plus sin A minus 1. Okay. In this exercise, most of the question, every time you will be converting tan to sin and cos, cot to sin and cos, keep on doing the simplification, and you will end up getting the proof apart from this particular question. Okay, here we need to like a certain way we have to do it, otherwise we will end up getting puzzled over here. Okay, it is also given that this identity we are supposed to use over here. Now if you will focus, let's take a pause and focus on left hand side and right hand side. Left hand side we are having cos sine, right hand side we are having cosec cot. If we will try making, till now I have not told you that focus on left hand side, right hand side, and try making right hand side from the left hand side. Okay, initially only. But here I would say, okay, let's try making right hand side from the left hand side. Cosec is there, cot is there. If we have to make cot cosec over here, what can be done on the left hand side? Can we divide numerator and denominator with sin A? Can we? Can we divide numerator and denominator with sin A? Is it allowed? Yes, it is allowed because it's a fraction. And until or unless we are doing the same thing in numerator and denominator, it is allowed. Why we are doing so? Because we are focusing on the right hand side. Okay. So let's do it. Cos A by sin A will be what? Minus sin A by sin A plus 1 by sin A. Any confusion so far? You have to write it in bracket, dividing numerator and denominator by sin A. Okay. Here also in denominator also it will be cos A by sin A plus sin A by sin A minus 1 by sin A. Any confusion so far?
No.
Cos A by sin A will be what? Cos A by sin A will be what? Is it cot A? Is it? Is it cot A? And here it is cosec A?
Yes.
Yes. Any confusion so far?
No.
Okay, now we are supposed to use this identity. We will keep in mind that we are supposed to use this identity over here. Okay, so if we have to use this identity over here, cot A plus cosec A minus 1, I am keeping just same thing I am writing cot A at first, then the last term, this cosec A I am writing over here, this cosec A, and then minus 1 I am writing. Okay, here cot A, you can write cosec A over here and then plus 1. We are not doing any changes. We are just writing cot cosec together. Okay. Now at the place of 1, we will be using the identity. At the place of 1 here, we are going to use this identity which is initially mentioned in the question, that use this identity. In this format only we are not supposed to use, like we can use this identity anyway. For cosec we can use, for cot we can use, for 1 we can use. So we are going to use it for 1. We will be using that 1 is nothing but cosec square hai minus cot square. Okay, we will be at the place of 1, we are going to write cosec square a minus cot square a. Let's do it. At the place of 1, we are going to write cosec square a minus cot square a. Any confusion so far? Please let me know.
No, ma'am.
Okay, in denominator, as it is, we will copy paste. Now, again, we have created the structure. See, a plus b, a square minus b square, which can be written as a plus b in one bracket, a minus b in another bracket. Why we will write a plus b, a minus b? Because this is what we are having in hand. A plus b already we are having in hand. If from there also we will generate cot a plus cosec a, cot a minus cosec a, if we will generate from there, then we can take it out as a common factor. Am I making sense to all of you? From
Yes.
here we will be able to write cosec a minus cot a and cosec a plus cot a, and this two are common factor. Can you see the two circled? Can you see it? Yes or
Yes.
no? Let's continue. We will write for that part, we will be writing cosec a minus cot a minus b in one bracket, a plus b. Okay, here we are having cot a plus cosec a already. Okay, we will be taking out common cot a plus cosec a. And we are left with 1 minus this bracket, cosec a plus cosec a minus cot a. Any confusion so far? Anyone having any confusion so far?
No, ma'am.
Okay, in denominator we are having as it is. We are not doing anything in the denominators part. Okay. Now here, let's open the curly bracket. It will be 1 minus cosec a plus cot a. And that's what we are having in the denominator. Check it. That's what we are having in the denominator. Cot is positive, cosec is negative, and 1 is positive. That means even if the terms are sitting here and there, it's exactly same. Minus 3 plus 4 plus 7. Minus 3 plus 4 plus 7, or 7 minus 3 plus 4. It's the same thing. Okay? It's the same thing if the sign